This webcast talks about how to perform the lab to explore how energy is stored in a spring. You can download the template for the lab from Schoology page 6.4. It's this Word document here, Lab Energy Stored in a Spring. Once you've downloaded that document, we're going to go through it step by step. So the purpose here is that we're going to find the relationship between the distance that a spring is either compressed or stretched, I guess it should say compressed or stretched, and the amount of elastic potential energy that gets stored in the spring as a result. And so there are two independent variables in this study: the force that has to be applied to the spring to cause the displacement, and the elastic potential energy that gets stored in the spring. Okay, so notice the names we're giving to these. The applied force is F sub A, and the elastic potential energy is E with an EL subscript. We're going to use one of the University of Colorado simulations for this lab, and so you need to go to this link here. And once you get there, you want to click on the icon that's labeled energy. So let's see, so here I am at the University of Colorado simulation. I'm going to click on energy. Okay, I'm going to reset. So once you get into the energy part of the simulation tool, please click on force plot, and then put check marks in all of the boxes below that. Okay, so we're going to display energy, the applied force, the displacement, the equilibrium position, and the values. Okay, so we've now completed through step 4 of the lab. Now it says to select a value of the spring constant and record it here. And so I want you to choose any value that you want of the spring constant. Notice that the values range from 100 to 400. So please choose your own value. Don't use the version that I'm going to use in the example. Maybe I'm going to pick 320. No, I'm going to pick 400 in my example, but don't choose 400. You choose a unique value. Okay, but after you have chosen it, then you need to write the value here in step 6 so that you don't forget it. Okay, we'll need that later. Then step 7 says explore what happens when you change the value of the displacement of the end of the spring. Okay, so initially, if you look, here is where it gives you the displacement. It's 0, and so the end of the spring is right here on this dotted green line. That's the equilibrium position of the spring. That's where it is relaxed. There are no forces being applied. See, 0 newtons of force being applied to the spring, and so it is very relaxed because of that. But I can pull the spring to the right, and look what happens as I do that. It takes a force to stretch the spring, and so this value up here on the force versus displacement graph gives me the amount of that force, and then here is the displacement. And so if I keep stretching it to its limit, it shows how much force it would take. But I can also compress this spring, so I can bring this arm and push it to the left, and notice how it's getting all scrunched up, and it takes more and more force to make it move to make it compress. Notice that these are negative forces because it's being displaced in the negative direction. So the forces for me go from negative 400 at the left end, the most compressed, to 400 at the most stretched. But yours may be different because you are going to choose a different spring constant. Okay. So that was 7. So now we're going to fill in the table 1. And so notice here, this is going to be a table where we're going to record, we're going to set different displacements, we're going to record the applied force, and then we're going to also record the stored elastic potential energy. So first it tells me to set the displacement to -1 meters. And so I'm going to move this bar all the way to the left so that my displacement is -1 meters. I'm reading off the force here. It says -400 newtons, and so I will record that in my table. And now I also want, over here on the left, it shows potential energy, and I want to record the amount of the potential energy. And so this says 200 joules. Okay. Then I'll go to the next row of the table. Now I'm going to set the displacement to -0.8 meters. And so I'm going to come back a little bit until I'm at -0.8. It's hard to get right on the negative. Oh, maybe I can type it in here. So I can use these little arrows here to set the displacement at -0.8. And I see that the force, when the displacement is -0.8, is -320. And so I'll record that. And then the stored elastic potential energy is now 128 joules. Okay, pause this video. Or actually, I'm just going to end the video here. You need to complete Table 1. Fill in every row of this table before you go to the next video.